Hi, my name is Sean Ray, and today I'm going to be talking about the progress of my alum crystals so far. So as you can see, there's been no growth, but that is not unexpected. In fact, we've been told that it will take a couple weeks, and that the longer that we let the crystals grow, the purer and larger they'll become. So I'm happy that there's no growth yet. Some details, I've been keeping it on top of my desk near the window, but there's been no sunlight access. And as a personal thing, I named it Walter after like Breaking Bad crystals. Okay, the process of making these crystals was really interesting and very fun. Not to go into the actual details, but the overall process was synthesizing it starting from a aluminum foil and then a ton of steps of purifying it and just getting it to be as purified as possible, because as I said, the purer it is, the better the crystals will become. So it was split into 3 overall procedures. The first one involved a couple of reactions. It was mixing the aluminum foil in the strong base potassium hydroxide, filtering that, and then in 2 separate reactions, we added a strong acid, H2SO4, and then filtered that through stirring it with a magnetic stir and heat just to get rid of any impurities. And then in the second procedure, we did 3 vacuum filtration processes through mixing it with a 50-50 ethanol and water mixture, and this is just to purify it even more. And then finally, in the recrystallization step, we mixed a certain amount of the alum powder, which was determined by the solubility of the alum at 25 degrees Celsius, or I think 20 degrees Celsius, in water, and we wanted it to be a saturated solution. An interesting thought process I had was how this would differ if we were trying to synthesize a different type of crystal, such as table salt or NaCl. And in my opinion, I think that the overall process would be very similar of, starting with a reactant and then going through the process and multiple steps of synthesis, but I think the individual details would be different. For example, it'd be possible that we used a different strong base and a different strong acid depending on the actual reactants and products of the individual reactions. Another thing is that I think we'd mix a different amount of the powder into the water during the recrystallization procedure. We mixed 4.6 grams of alum because that was based on its solubility at room temperature, but NaCl will have a different solubility at room temperature. And this type of thing inspires me to do more at-home processes of crystal growth in science, and one really interesting process that I found on Scientific American, and I'll cite that source, is how to make borax crystals. The process is boiling water and then pouring the water into 2 separate jars, and then adding a specific amount of borax into each jar once the water's cooled down until saturated. So you add more until no more will dissolve, and then you tie an end of a string around 2 pencils and lay the pencils across so that the string is in each solution. Cover that in plastic wrap, and then one of the jars goes on ice. And at the end of this, you'll see that the borax in the hot water formed fewer crystals, but they were in better shape than the ones in the cold water. And this is because the one in the cold water had more impurities. If I had to criticize this step though, is because in this process on Scientific American, they just recommend leaving the crystals in for 5 hours. And I think that if you left it in for longer, the crystals would be better because there would be fewer impurities. And then I also think that they should incorporate more filtration methods such as stirring and heating. So yeah, that's the progress so far, and I look forward to seeing how it's going to grow in the next couple weeks.